you can use to explore some symmetries of a few functions. So in order to use this graph, I have some built-in functions here, and I can show a function by actually clicking on this. I recommend that you don't click on this arrow yet because that is kind of a little bit of a spoiler and takes away some of the thinking for you. So here is a graph of a function f, and I am wanting to determine what kind of symmetry f has. And in determining that, one of the tools we use for talking about symmetry is what happens to f on symmetric inputs. And so there's a couple different types of symmetric inputs. One of them is opposite inputs, and the other is spaced inputs. So here is an input and then an input plus a fixed distance away from it. That's the spaced inputs, and the opposite inputs are, here is one input and then it's opposite. So here's A, and then it's opposite negative A. And I think if I click on that point, nope. If I click on this point, nope, never mind. But here I can say A is approximately 3-ish, and then negative A is -3, and vice versa. If I set A to -2, then the opposite of A is +2. So I can look at what happens to this function f on opposite inputs. And if I click on this circle here, it will actually show what happens to f on opposite inputs. So here, if A is at -2.34, if the input is -2.34, then the output is 0.814. And at the opposite, if the input is +2.34, then the output is -8.14. And when I drag this around, I will see that opposite inputs will give opposite outputs. So if you remember what kind of a function gives opposite inputs for opposite outputs, opposite outputs for opposite inputs, you might remember that this function is called an odd function. And I can click on this and see that f is an odd function. And for opposite x values, the y values are opposite. This is not a calculation. This is sort of a, just a little note. What happens to the output on x versus the output on the opposite of x? And the answer is the opposite, f on -x is the negative of f on x. This is the definition of the function here. If you want, you can play around and change this function and see what happens. If I was to say square x, then you're going to get a new function, and this is no longer going to be a valid statement necessarily. Okay. And if I was to open this triangle here, there's a whole bunch of stuff that kind of draws all of these parts. You are welcome to look at what is going on there, or just leave it closed and assume that it's doing the thing that it's supposed to be doing. All right. So I'm going to close these up, and I'm going to show G. Now what's happening? What kind of symmetry do you see? I still have my opposite inputs being shown. Those are down here in line 65. Oops. And I'm kind of asking what is happening to the outputs on opposite inputs. And so I can show G on opposite inputs, and I can see it looks very much like the outputs are the same for opposite inputs. Now, what kind of function has outputs the same on opposite inputs? And you can also see what symmetry does this graph have when the outputs are the same for opposite inputs. You can click on this triangle to reveal the answer, but I strongly recommend that you play with this, look at the behavior, think about the symmetry yourself before you click on that and find the answer. Okay. Looking at H, we can see now what's happening with H with opposite inputs. What kind of symmetries do you see in H? And if I look at what is the outputs for opposite inputs, what do you see happening here? Do you see a symmetry with this function? Okay. Again, I don't really want to display answers here because I want you to play and explore it yourself. Here's another one. So here is a function that has we can look at k on opposite inputs. And we see that opposite inputs actually give opposite outputs. But there's another symmetry happening here too. So in addition to the fact that there's this sort of like, if you go to the left and down, that means you can also go equal distances to the right and up, right? So that actually gives a sort of rotational symmetry. We talk about it as being symmetry through the origin or symmetry about the origin. But there's another symmetry happening here too, which is that there's this repetition. So the function is being repeated over and over, and that's a different type of symmetry. So instead of opposite inputs, we're going to look at spaced inputs and show k on spaced inputs. And we see that if I space my inputs apart by 6 units, then my outputs are the same. Now, in the spaced inputs, if you want to explore a different function, k, then you can go into spaced inputs and you can change that spacing. So right now the spacing is set at 6. I could change it to 8, and we will see, like, with a spacing of 8, the outputs are not the same. Okay, so this is a little graph that you can use to explore different functions. You can explore the functions that are built in here. You can also go in here, and if you wish, you can put in your own functions and explore the symmetries that are there.